Welcome to Ethical Board Education. I'm Navya. In this session, we will be learning how to design the circuit using the TinkerCAD. This TinkerCAD is a free online collection of the software tool that helps people all over the world to create, to think, and to make it. So in this, there are three main designs which you can create. That is the 3D images and the electronics and the code blocks. But in this session, we will be discussing all about the electronics part. In this electronics part, we will be learning how to design the circuit and how to code the circuit, how to write the program and to simulate the circuit to check whether the circuit is properly working or not, and finally to assemble the circuit. So now we will start with the sign in operation. Now we have to sign in by the any one of the three user ID. I'll be signing through my Gmail account. Otherwise, you have to create an account. So my first page, it looks like this. Yes. So this is my first page. And in the left hand side, you can see there are like three designing tools are there. One is the 3D images, the second is the circuits and the code blocks. So it depends on your design. If you want to design, you can just choose the particular area. So I'll be designing the circuit. I'll just clicking on the circuit and then I have to create a new circuit now. So these are all my old circuits, whatever I have designed in the previous session. So this is the new circuit area. I mean the new designing area. Yeah. So this is the blank page. Here you will be designing the circuits. In the right hand side, you can observe there are a list of components. If we are not aware of those components, we can just click on this. Then we can just know the basics of about all the components. And to select the components, you have to click on the drop down. There you will be getting a list of the components. Arduino, it consists of the Arduino boards and basics. You have some basic model of the circuits. All contains about all the short components over here. And in the right hand side, you can just see so there are some icons, and in the left hand side also there are some icons. So the code is nothing but you can write the code program over here. By clicking on this, you can see the codes present there. If you click on the Arduino project, you will be getting the codes. Start simulation, this is for the running of the project. There will be the start and also the stop simulation will be there. This is for the exporting and also you can share it. And in the left hand side, this is the rotate option. Suppose if I take any a parameter, any component, if I take an LED, if I click on this, you can rotate the object, you can delete the object, you can go back and forward, and also you can view or hide the component, and you can also use the annotation. Now I will be designing a basic circuit of lighting up an LED. For lighting up an LED, all I need is the LED and I need the battery to light up the LED. I have to search by in the right hand side. Yeah, so I'll be connecting to the LED. For battery, we all know there are two terminals, positive and negative. LED, two terminals, anode and cathode. Always anode we used to connect to the positive and cathode for the negative. You have to click on the starting point of this and you have to drag the line and you have to click for some place. You have to join to the particular place. Now my connection is completed, because here there is no overlapping and there is no open circuit. It is a closed path. Now I can start the simulation, and here we can observe it burns out. There's a burst in the LED. So why it is got burst is because here we sent too much of current, so it got burned. To limit the flow of current, we can add up some component. So that is nothing but the resistor. Why? Because it limit the flow of the current. So I'll be adding up a resistor. I'll be just deleting the lines, the wire lines. I'll be connecting anode to the resistor and resistor to the positive of the battery and negative to the negative of the battery. Then I'm starting a simulation. Yes, there is no burst out here. You can observe, you can zoom out and you can observe there is no burnout. It glows well. It is in good working stage. When you start the simulation here, we can observe the time of the simulation part. Suppose if we are giving some delay to for some seconds here, we can observe it and we can just conclude that whether it is working well or not. We can zoom in, and then so here it is limiting the flow of the current. Current is nothing but the flow of charged particles. And now suppose if I want to connect more LED to the same battery, means I can just take out the resistor, whatever amount of resistor I wish, with the LED, and the connection is same, similar what we have designed for the first LED. Anode to the resistor, and for the battery, and the negative of cathode to the negative terminal of the battery. Here, this point and the end of the point, it must match, otherwise our circuits may break. The red point, whichever it is showing. Yeah, here you can change the color of the LED. Yeah, and also the lines. You can change out the lines, which resembles the black connection part. Black stands for the negative. You can just name for that particular area. I'm going to the start simulation. So each LED is glowing as well, and there's no burnout because we are using a resistor. So it is limiting the flow of the current. This is how it works. And then to check the voltage of this battery, we have a special device that is known as the multimeter. So through this multimeter, we can check whether it is 9 volt or it is more than that. All about is you have to connect the multimeter to the terminal of the battery, and you can just start stimulation. Then you can observe it is showing as 8.97 volt. That means it is exactly at almost near to the 9 volt of battery. That is how you can check through the multimeter. Here you can also check the current, voltage, and the resistance value. And here you can change the resistance value by clicking on the resistor. By clicking on the resistor, you can change the value of the resistor. You can enter as the value so that you can observe there is a change in the color of the resistor. When you start simulating, it works well. And then here, if we observe, the connection is like it's not in a proper order, it is like full of jumble. So to make a proper connection, what I can do, I will be using a special one. To make a proper connection, I'll be using a breadboard. I'll be designing the same circuit but with the use of the breadboard, and let us know how it looks instead of this like jumble connection. How does it look in this breadboard? So I'll just delete up all the wires, and then I'll be connecting the same wires with a breadboard connection. I'll be using the same amount of resistor and the and the LEDs. This is not required. I'll just delete this. Yeah. So now we required a 3 resistor and the 3 LEDs for the connection part, and we need 3 LEDs and one battery we need for the connection purpose. And let us see how it looks after the connection. Yes, battery we can rotate. Yes. Okay. Now, before connecting, let us know how we need to connect this to the breadboard of all the components. Hmm. Here we can observe the top and bottom are shows as positive and negative. In the bottom as well as in the top. These all are connected in the series, in the same line, in the same path. It resembles the same connection. All are connected together in a series wise in a horizontal way. Whereas here we can observe those are connected in the parallel ways. This line has the complete connection. So each line has its own connection in the vertical path in a parallel way. So this point, if I connect all the points as the same connection, if I connect to this point, this all the lines, this all the points have the same connection. The complete line has the same connection. What I do, I'll just take out this. Yeah, I'll just take out this resistor and I'll be keeping here. This is an LED. I have connected this anode to the resistor part and other end of the resistor to the positive terminal of the battery. I'll be connecting to any one end point of this line so that it resembles all the connections. It gets all the connections of the same line. And then the other end is to the negative. I'll just connect to the negative, and this terminal I'll be giving to any one point, and same as like all the component, other component. The same point I'll be rotating and just I'll be giving here. The anode part. This line resembles the same connection. This is the positive. If this is connected, this is also will be connected in the same line, and other part to the negative, and this also the similar, even this as a connectivity, and this negative to the negative one, because this all negative are connected to the negative of this line. So it everything is connected now. Now the connection looks very simplex. It is not a complex one. It is too simple. The connection looks too simple. I'll be starting the simulation. Yes, everything is glowing. All three LEDs are glowing. Here we haven't changed the color of the LED. That is why we are getting all the red one. If I change the color of the LED, then if I start simulation, then we can observe that all LEDs are glowing with a particular colors, and this connection looks very simple with the help of the breadboard compared to the previous connection which we had in the jumble kind of thing.